The first thing you'll have to be able to do in 5-6 solving system of inequalities is to tell whether the ordered pair is a solution of the given system. So they give us an ordered pair. In the first example, A, they gave us 2, 1. Remember, 2 is the x, 1 is the y. And so I'm going to plug those in to my inequality in the correct spots and see if this comes out true in both. If it does, then this is a solution of this system. So for the first one, it would be 1 is less than -2, because I'm plugging in the 2 into that negative x. So it'll be -2 plus 4, which is 2. 1 is less than 2 is true. And then I do it the same thing to the second inequality. So 1 is less than or equal to, x is 2. So less than or equal to 2 plus 1, which is 3. And that's also true. So this one is a solution, so yes. Pause the video and try the second one, example B, and then I'll give you the answer to that. So this ordered pair did not satisfy the first inequality, but it did for the second, but it's still a no. Once one of them is a no, this ordered pair cannot be a solution of the system. The next thing you'll have to be able to do is graph the system of linear inequalities. In order to graph, we need our y isolated. Usually be y equals mx plus b. Now this is an inequality, so it might be y is less than, y is greater than or equal to mx plus b. So regardless, in the first inequality, it is not set up for graphing. So normally I would subtract 8x from both sides first, so I'm going to do that, and I end up with 4y is less than or equal to, since I moved the 8x to the other side or subtracted it, became negative 8x, and then there was a plus 12. And then I divide everything by 4, and I get y is less than or equal to negative 2x plus 3. So now I have my two isolated inequalities that I'm going to graph. I want to remind you that if it's greater than or less than, it's going to be a dotted line. And if it's less than or equal to or greater than or equal to, it's going to be a solid line. So I know that I'm going to have one dotted, one solid. So I'm going to graph as normal. I'll graph the first one in red. The one on the left here, I should say, the second inequality, really. Y is greater than 1/2 x minus 2. I'm going to start at -2. And my slope is positive. I'm noticing that. I'm going to rise 1 and run 2. Up 1 over 2. Do that again. Up 1 over 2. Remember that it's a dotted line. And I need to test a point now. It's greater than. It's going to be above the line. But I'm going to test a point to make sure. So I'm going to test 0, 0 and see if I'll be able to shade that. So 0 is greater than 1/2 times 0 is 0 minus 2. So 0 is greater than -2. And that's true. So for this one, I'd be shading all of this area where the 0, 0 fell in, because since it was true, I'm shading the true side. Now if I look at my second, I'll highlight that one blue. If I look at my second one, let's highlight this pink. I'm going to graph this line. I'll graph this in, what do I have for options here? I'll just graph it in black. Okay, so +3 is where I'm beginning at my y-intercept, My slope is negative, so I'm going to go down 2 to the right 1. Do that again, down 2 to the right 1. I see that they intersect, but I'm not worried about that anymore. I need to see about their shading. Down 2 over 1. And this one was a solid line, since it was equal to. So lots to think about in these problems. And now I'm going to test a point. So I can go ahead and test 0, 0 again. So 0 is less than or equal to negative 2 times 0 is 0, plus 3 is 3. 0 is less than or equal to 3. That's true. So I'm going to shade on the left side of that line. And wherever we see that double shading, oh, and here, really, I'm going to color it yellow. All of this that was red and blue, those are my solutions to the inequality. So I could pick any of those points and it's a solution. For instance, this point right here that I just made in light green, that's negative 3 comma 0. That is a solution to the system of inequalities. Try this problem and pause the video. When you're ready for the answer, go ahead and unpause. So I've graphed both lines and shaded the appropriate areas. And where the double shading is occurring is where I'm highlighting green. All of these ordered pairs that fall in this spot in between these two lines are the solutions of the system of inequalities. You may notice before I even graph these two lines that they are parallel because they have the same slope. These are drawn poorly, but they are parallel lines. So after testing 0, 0 for both lines, I see that my solutions fall in between these two lines based on the double shading. When we graphed systems of equations and we had parallel lines, since they never intersected, we said they had no solution. But notice now when you graph systems of inequalities and they're parallel lines, you can still have solutions.